These duplex spacers are likely from the mid to late 1960s based on their three-prong configuration. MoMA Incorporated was a manufacturer of electrical products, including receptacles, switches, and other wiring devices. The company was founded in the 1950s and was based in Los Angeles, California. These duplex spacers would not meet current code requirements due to the exposed wood around the receptacle. Under the National Electrical Code, the faceplate of a receptacle must be flush with the wall surface, and the receptacle box must be flush with the faceplate. The exposed wood around the receptacle could pose a safety hazard, as it could become a point of contact for electrical current. Additionally, the open area around the receptacle could allow dust and debris to accumulate, which could lead to electrical problems. Let's delve deeper into the National Electrical Code, or NEC, requirements regarding receptacle installations and safety. The NEC is a comprehensive set of guidelines designed to ensure electrical safety in buildings. It's updated every 3 years to reflect the latest advancements in technology and safety practices. When it comes to receptacles, the NEC has specific rules about their installation to minimize the risk of electric shock, fire, and other hazards. Firstly, regarding the flush mounting requirement, this is outlined in NEC section 406.5. This section mandates that receptacle faceplates be installed so as to completely cover the opening and seat against the mounting surface. The purpose of this requirement is to prevent accidental contact with live electrical parts and to prevent debris from entering the electrical box. Secondly, box fill calculations are crucial. NEC Article 314 covers outlet boxes, conduit bodies, and handhole enclosures. It dictates the maximum number of conductors, devices, and fittings that can be installed in a box. Overfilling a box can lead to overheating, insulation damage, and potential electrical hazards. The NEC specifies box fill calculations based on the volume of the box and the size and number of conductors, devices like receptacles, and fittings within the box. Thirdly, conductor sizing and ampacity are vital. NEC Article 310 provides guidelines for conductor ampacity, which is the maximum current a conductor can carry continuously without exceeding its temperature rating. The size of the conductors used to wire a receptacle must be sufficient to handle the load it's expected to carry. Using undersized conductors can lead to overheating, voltage drop, and even fire. Fourthly, grounding requirements are essential. NEC Article 250 covers grounding and bonding. A properly grounded electrical system provides a low impedance path for fault current to return to the source, tripping the circuit breaker or fuse and de-energizing the circuit. Receptacles must be properly grounded to protect against electric shock. This typically involves connecting the grounding terminal of the receptacle to the grounding conductor in the electrical system. Fifthly, GFCI protection is needed in certain locations. Ground fault circuit interrupters, or GFCIs, are life-saving devices that protect against electric shock. NEC Article 210.8 requires GFCI protection for receptacles in certain locations where there's a higher risk of electrical shock, such as bathrooms, kitchens, garages, and outdoor areas. A GFCI monitors the current flowing in the circuit and quickly interrupts the power if it detects a ground fault, preventing a potentially fatal electric shock. Sixthly, FSI protection is also needed in certain locations. Arc fault circuit interrupters, or FSIs, are designed to protect against fires caused by arcing faults. An arcing fault is an unintentional electrical discharge that can occur due to damaged or deteriorated wiring. NEC Article 210.12 requires FSI protection for receptacles in certain locations, such as bedrooms, living rooms, and other areas where arcing faults are more likely to occur. An FSI detects arcing faults and quickly interrupts the power, preventing a fire from starting. Seventhly, tamper-resistant receptacles are necessary, especially where children are present. Tamper-resistant receptacles, or TRRs, have internal shutters that prevent the insertion of foreign objects such as paper clips or toys. NEC Article 406.12 requires TRR in dwelling units and childcare facilities to protect children from electrical shock. Eighthly, weather-resistant receptacles are needed for outdoor use. Weather-resistant receptacles are designed to withstand exposure to rain, snow, and other outdoor elements. NEC Article 406.9 requires weather-resistant receptacles in damp or wet locations, such as patios, decks, and pool areas. These receptacles are constructed with corrosion-resistant materials and have watertight covers to protect against moisture. Ninthly, proper box mounting is key. The electrical box must be securely mounted to the wall or other supporting structure. NEC Article 314.23 provides requirements for box mounting, including the use of appropriate fasteners and supports. A properly mounted box ensures that the receptacle is securely held in place and that the wiring connections are protected. Tenthly, regular inspections and maintenance are crucial. Electrical systems should be inspected periodically to identify any potential problems, such as loose wiring, damaged receptacles, or overloaded circuits. Regular maintenance, such as tightening connections and replacing worn-out components, can help prevent electrical hazards and extend the life of the electrical system. The exposed wood around those vintage receptacles is a significant safety concern. Wood is combustible and can ignite if exposed to heat or electrical arcing. If there's a loose connection or other electrical fault within the receptacle box, the exposed wood could easily catch fire. The NEC requires that electrical boxes be made of non-combustible materials, such as metal or plastic, to prevent the spread of fire. The open area around the receptacle is also a concern because it allows dust, debris, and other foreign objects to enter the electrical box. These materials can accumulate over time and create a conductive path between live electrical parts and ground, leading to a short circuit or ground fault. Additionally, the open area could allow insects or rodents to enter the box and damage the wiring insulation, creating a potential fire hazard. The NEC requires that electrical boxes be tightly sealed to prevent the entry of foreign objects. Furthermore, those vintage duplex spaces may not have been tested and listed by a recognized testing laboratory, such as Underwriters Laboratories or UL. UL listing indicates that a product has been tested and meets certain safety standards. Using unlisted electrical products can be risky because they may not have been designed or manufactured to the same safety standards as listed products. This could increase the risk of electrical shock, fire, or other hazards. The NEC requires that electrical products be listed by a recognized testing laboratory to ensure that they meet minimum safety standards. Modern receptacles are designed with a number of safety features to protect against electrical hazards. These features include tamper-resistant shutters, which prevent the insertion of foreign objects, and weather-resistant construction, which protects against moisture. Modern receptacles are also designed to be installed flush with the wall surface, eliminating the exposed wood and open area that were present with those vintage duplex spaces. When replacing old receptacles, it's important to choose modern receptacles that meet current safety standards and are appropriate for the intended use. It's also important to follow all applicable electrical codes and regulations to ensure that the installation is safe and compliant. Consider a scenario where someone touches the exposed wood around the receptacle while also touching a grounded metal object, such as a plumbing pipe or appliance. If there is a fault in the receptacle wiring, the person could receive a dangerous electric shock. Even if the person doesn't touch a grounded object, the exposed wood could still provide a path for electrical current to flow through their body, resulting in an electric shock. The severity of the shock would depend on the voltage and current involved, as well as the person's physical condition. Another scenario involves a child inserting a metal object, such as a paper clip or toy, into the open area around the receptacle. If the object comes into contact with live electrical parts, the child could receive a severe electric shock. Tamper-resistant receptacles are designed to prevent this type of accident by blocking the insertion of foreign objects. Now let's examine the specific NEC articles that address the issues raised by those vintage duplex spaces. NEC Article 314 covers outlet boxes, conduit bodies, and handhole enclosures. This article specifies the requirements for the construction, installation, and support of electrical boxes. It also includes requirements for box fill, which is the maximum number of conductors, devices, and fittings that can be installed in a box. NEC Article 406 covers receptacles, cord connectors, and attachment plugs or cord caps. This article specifies the requirements for the construction, installation, and wiring of receptacles. It also includes requirements for GFCI protection, FCI protection, and tamper-resistant receptacles. NEC Article 210 covers branch circuits. This article specifies the requirements for the installation of branch circuits, including the number and type of receptacles that are allowed on a circuit. It also includes requirements for GFCI protection and FCI protection. NEC Article 250 covers grounding and bonding. This article specifies the requirements for grounding and bonding electrical systems to protect against electric shock and fire. It also includes requirements for the grounding of receptacles. NEC Article 110 covers general requirements for electrical installations. This article includes requirements for workmanship, equipment listing, and labeling. It also includes requirements for the use of approved materials and equipment. When evaluating an electrical installation, it's important to consider all applicable NEC articles and to ensure that the installation meets all of the requirements. If there are any questions or concerns, it's always best to consult with a qualified electrician. Replacing those vintage duplex spaces with modern receptacles is a relatively straightforward project, but it's important to take the necessary safety precautions. Firstly, turn off the power to the circuit at the circuit breaker or fuse box. This will prevent electric shock while you're working on the wiring. Secondly, test the circuit with a voltage tester to make sure the power is off. Even after turning off the breaker, it's always a good idea to double check to be sure the circuit is energized. Thirdly, remove the old receptacle and disconnect the wiring. Carefully examine the wiring insulation for any damage. If the insulation is damaged, you may need to replace the wiring. Fourthly, connect the new receptacle to the wiring. Be sure to connect the wires to the correct terminals. The black wire goes to the brass terminal, the white wire goes to the silver terminal, and the ground wire goes to the green terminal. Fifthly, install the new receptacle in the electrical box and secure it with screws. Be sure to tighten the screws properly, but don't over-tighten them. Sixthly, install the faceplate on the receptacle. The faceplate should fit snugly against the wall surface. Seventhly, turn the power back on at the circuit breaker or fuse box. Finally, test the receptacle with a receptacle tester to make sure it's wired correctly. If the receptacle tester indicates a problem, turn the power off and check the wiring. If you are not comfortable working with electricity, it's always best to hire a qualified electrician to do the job. An electrician has the training and experience to safely and properly install electrical equipment. In addition to replacing the receptacles, it's also a good idea to inspect the wiring in the electrical box. Look for any signs of damage, such as cracks, cuts, or discoloration. If you find any damaged wiring, it should be replaced by a qualified electrician. It's also important to make sure that the electrical box is properly grounded. The grounding wire should be securely connected to the grounding terminal in the box. If the box is metal, it should also be grounded to the metal conduit or cable that supplies the power to the box. The information provided here is intended for informational purposes only and should not be considered as a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. Electrical work can be dangerous and should only be performed by someone who is trained and experienced in electrical safety. Failure to follow proper safety procedures could result in serious injury or death. When working with electricity, always take the necessary precautions to protect yourself from electric shock. Wear appropriate safety equipment, such as rubber gloves and safety glasses. Work in a well-lit area and avoid working in damp or wet conditions. If you are not sure how to do something, ask a qualified electrician for help. The National Electrical Code is a complex and comprehensive document, and it's important to stay up to date on the latest changes and requirements. The NEC is updated every 3 years, and each new edition includes revisions and additions to the code. Staying informed about the NEC can help you ensure that your electrical installations are safe and compliant. There are a number of resources available to help you learn more about the NEC. You can purchase a copy of the NEC from the National Fire Protection Association, or NFPA. You can also find information about the NEC on the NFPA website. In addition, there are many online resources and training courses available to help you learn more about the NEC. By taking the time to educate yourself about electrical safety, you can help protect yourself and your family from electrical hazards. Remember, electricity is a powerful force that should be treated with respect. Always follow proper safety procedures when working with electricity, and never take shortcuts. Your safety is worth it. Also, remember to check your local jurisdiction and building codes for any electrical requirements, and always consult with a licensed electrician for a professional and safe repair.